Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Farid bin Abdul Jalil and my team is AFIQ bin Muhammad AZMI and Muhammad Adam Hakim bin Muhammad ZAIDI. We are from Group 3 from EE2233B, want to do a presentation of Lab 2. This is the question that our group got, which is the question 3, that we have LED 0 to LED 7 connected at port PB0 to PB7 with 3 patterns with different condition of switch as shown in table Q3. This is our schematic diagram for the question 3. First of all, we have the switch. We have two switch, which is switch 0 and switch 1. For switch 0 connected to the PC1 and switch 1 connect to the PC13. And the input is the active flow. And for the output, we have 8 LED, which is from PB0 to PB7, and the output is active high. Next, we go to the configuration table. First of all, we have RCC underscore AHB1 ENR, which is to enable the port, which is we have two port, which is port B and port C. For port B, we have 0010, which is 2, and port C 0x0100, which is 4. Fill the unconnected with 0. For the GPIO-B model, which is output, we have 2, which is that's BIC and ORR. For BIC, we fill the connected with 1 for the model from model 0 to model 7. So we have BIC equal to 0x0000 FFFF. The unconnected fill with 0. For ORR, we fill the connected with 01 from model 0 to model 7. This for the LED from LED 0 for 7. The result we have 0x00005555. Next, we have GPIOC underscore model. This is for input, which is the switch, and fill the connected with 1, which is model 1 for switch 0, and model 13 for switch 1. So the result we have 0x0C00000C. We go to the GPIOC IDR. This one for input, and as we know, the input is active flow. So first of all, we use the masking and for enable the pin. This for switch 0, the IDR1 we fill with the 1, and switch 1 we IDR13 we fill with the 0, and fill the unconnected 0 unconnected with 0. So with the result is 0x00002002. Okay, we go to the condition 1, which is the switch. For the switch 0, we off. So we'll fill the 1 because this is the active flow. And switch 1 is on, we fill the 0. So the result is 0x000000002. For condition 2, the switch 0 is on and switch 1 is off. So we fill the IDR1 with 0 and IDR13 with 1. So the result is 0x00002000. Condition 3, the switch 0 is on and switch 1 is on. So the IDR1 we fill the 0 and IDR13 we fill the 0. And the condition 3, the result of the condition 3 is 0x00000000. For default condition, for the switch 0 off and switch 1 off, so we fill the IDR1 1 and IDR13 1. So the result, we have 0x0000200002. For GPIOB ODR, which is for output, and as we know, the LED is active high. So for the condition 1, we fill the LED that on with 1 and the LED off with 0. So for the condition 1, the result is 0x00000005A, and condition 2, 0x000000A5, and condition 3, 0x000000C3, and for default condition, the result is 0x00000000.
Assalamualaikum. My name is Muhammad HAKIM. Today I will talk about our group flowchart for Lab 2 question number 3. So first of all, if we start the program, the first thing first, it will enable the port B clock by enable GPIOB. After that, it will enable GPIOC clock to enable the port C. After that, it will set port B PB0 until PB7 to output mode, meaning PB0 until PB7 will become the output port for the STM. After that, it will set port C, PC1 and PC13 to input mode. So it will set this port C1 and port C13 into input. So after that, it will start to read value from the push button GPIOC underscore IDR, which is this switch value, switch 0 and switch 1. So this switch is an active low switch since it's near to the ground. So after it's starting to read the value from the push button, it will do masking, so we only read what is in the switch 0 and switch 1 only by only read from value for register 6 equal to port C1 and value of register 7 equal to port C13. So we start checking the conditions. So the condition first is switch 1 equal to 0 and switch 0 equal to 1, meaning that is switch 1 is on or switch 0 is off, because it's an active low, so it has to read 0 value. If yes, then the port B GPIOB ODR the STM will give value equal to 0x5A, causes LED 1, 3, 4 and 6 on. So the value that STM give must be equal to 1, because this is already 0. So this is 1 to create the potential difference in order for the LED to light up. After that, if condition 1 is not fulfilled, then we check another condition, is switch 1 equal to 1 and switch 0 equal to 0. If yes, it will do the condition 2. The GPIOB ODR will be equal to 0xA5, causing 0, 2, 5 and 7 to on. If still not fulfilled, then we check one last time, is both switch is pressed, meaning that switch 1 and switch 0 is having value equal to 0. If yes, then we will execute the condition 3, If not, it will detect that there is no push button is pressed, so both value switch 1 and switch 0 equal to 1, so LED will turn off. So after they done the condition, it will go back to the read value from the push button to detect if there is any change from the switch button input until the user wants to end the program. So that's all from me today. Thank you for listening, madam. Assalamualaikum.
Assalamualaikum. Today I will be explaining for the coding for Lab 2 question 3. So first we will have to define all of the memory addresses for the program to work. So there is 5 memory addresses that we have to define at the start. For the first one is RCC underscore AHB1 ENR. Second one is for GPIOB modder. The third one is for GPIOC modder. The fourth one is for GPIOB ODR, and lastly for GPIOC underscore IDR. So I will be explaining the memory addresses one by one and what's the function. So for the RCC underscore AHB1 ENR, so for the lab 2 question 3, there will be 2 ports that are used, which is port C and port B. Port C is for the switches, which is the input, and port B will be the output, which is the LED. Okay, so for the first step, we have to enable the ports that are used in the program, which is the port B and port C. So to enable it, we have to use RCC underscore AHB1 ENR for both ports. So for port B, from the configuration table, we will get hexadecimal 2. And for port C, we will get hexadecimal 4, number 4, which both of them will enable the 2 ports that are used, which is port B and port C. And secondly, for GPIOB underscore modder, this is to enable the output. This is to configure the output and enable it. So for GPIOB, which is port B, and it is the output, we have to do BIC and ORR, which is essential for outputs components. So we will get 0x0000FFFF for the BIC, and for the ORR we will get 0x00005555. And then we will have to do for the input, which is GPIOC underscore modder, which sets PC1 to input mode, which is switch 0. We will be separating switch 0 and switch 1. So for switch 0, BIC we will get 0x000000C, and for PC13, port C13, switch 1, we will get 0x0C000000. Okay, so here is the input condition for the switches for GPIOC underscore IDR. Note that the switch are active low, which means that when the switch is pressed, it is bit 0, and when the switch is not pressed, it is bit 1. So for the first condition, it is when switch 1 is pressed, which is bit 0, and switch 0 is not pressed, which is really going to be bit 1. Note that R6 is switch 0 and R7 is switch 1. So when switch 1 is pressed, R7, it is bit number 1. This will compare, and we can see that it is pressed, which is 0, and it will go to the second comparison, which is R6 switch 0, and in condition 1, switch 0 is not pressed, which will be bit number 1. So it will not go to the check number 2, it will go to the condition 1, because it's not equal to 0. is equals to 1. So we will go to the condition 2, the second condition, which means that switch 1 is not pressed, and meaning that R7 is number 1, is bit 1, and switch 0 is pressed, which means that it will be bit 0. So we go to check 2 and compare, and we see that R7 is hashtag 1, and we will go to the comparison, the second comparison, which is for R6, and R6 is pressed will equals to 0, and this means that it is gonna execute the second condition. And lastly, for the third condition, which is when both switches press, it means that switch 0, R7 and R6 is 0, bit 0. So compare R7 is okay. So compare R7, compare R7 is 0, which is equals to 0 because both of them are pressed. It will go to the second comparison, which is for R6, which is also 0, and it will execute the condition number 3. So for the check 4, when both are not pressed, it means that both R6 and R7 is bit 1. It means that all LEDs will be off, and we get the value for 0x0002 and 0x2000 for condition 4, the default condition. So here I will be explaining about the output condition of the program, which is the conditions of the LED. There will be there will be 8 LEDs that is in the program. So for the first condition, for the first GPIOB underscore ODR, when condition 1 executed, the LED 1, LED 3, LED 4 and LED 6 will be on. We will get the value from the configuration table of 0x0000005A. And for the second condition, which will be condition 2, the LED 0, LED 2, LED 5 and LED 7 that will be on, and hence from the configuration table it will be 0x000000A5. Oh, and I forgot to add that the LED is active high. So when it is active high, the bit 1 is on and the bit 0 is off. That's how we get the value for the conditions in here and in here. And for the third condition will be, and for the third condition for the output, LED 0, LED 1, LED 6 and LED 7 will be on. We will get the value of 0000000C3. And lastly, condition 4 will be the default condition when both switches are not pressed. For the default condition, it is 0000, all of it is 0 because all LED will not be on. There is a mistake in here. It has to be said that all LED is off. All LED is off. So that's all for our coding of this program. Thank you. Okay, Assalamualaikum. This is our result for question 3, lab 2. First I will introduce the LEDs, the working LEDs. This is LED 0 until LED 7. This is switch 1, internal switch, and this is the external switch, switch 0. Okay, first when we start press switch 0, which is the external, LED 0, LED 2, LED 5 and LED 7 will light up. So secondly, when we press the internal switch, which is switch switch 1, LED 1, LED 3, LED 4, and LED 6 will light up. And for the third condition, when we press both switches, LED 0, LED 1, LED 6, and LED 7 will light up. So we can conclude that we successfully execute the program. Thank you.
For the conclusion, this lab successfully demonstrated the implementation of ARM assembly language for controlling LED patterns based on different switch conditions in question 3. The predefined LED patterns on port B, which is PV0 to PV7, responded correctly to the combination of the user button, which is PC13, and the external switch, which is PC1, as specified in the given table. The result confirm proper configuration of GPIO inputs and outputs, a correct reading of switch states, and a correct bit manipulation to generate the required LED patterns. Overall, this thus strengthened understanding of conditional control and pattern generation using assembly language on the STM32F446RE microcontroller.